Another of the big ideas we're going to talk about throughout this entire year in Algebra 2 is something called an inverse operation. You've actually seen these before, but it's a really big important concept. So today we're going to look at what's something you already know about inverses and kind of introduce some of the verbs and terminology, and then get to see how it works a little bit with the mathematics today. And then we'll come back and visit this throughout the year. So first, I'd like you to take a second and go ahead and pause the video, and I'd like you to give an answer to each of these problems here, and then we'll keep going. So as you just finished putting in your numbers for these should be your answers. And then we're going to talk about these. First of all, I'd like you to notice what do you see about the very first and the very last numbers in each of these lines. And what we want to notice is that they are the exact same. They are the same numbers. And we want to say, that's really interesting. It's not all the time you get the same number out for your answer that you started with. So let's look at what happened in the lines. What patterns do we notice? When I say the mathematical operations, mathematical operation means the little symbols in here that we used. So what do we notice about these? Let's see, here we had a plus and a minus. Multiplication, division, minus plus, division, multiplication, plus minus, minus plus. First of all, one of the things we might notice is that you always see addition and subtraction together. You never see addition with multiplication in any of these lines here. So that's one of the things we could notice. Addition, subtraction always seem to go together. We always see multiplication paired up with division. Okay. So those are two things we notice. We might also notice you never see two pluses together. You never see two multiplications together. It's always one of each. So this pattern, the idea that you have one of each and you always have these two together and always have these two together, this is going to help us here. The definition of an inverse operation is something which undoes something else. Takes it back to its original state, if you will. So for example, to tie a shoe, the inverse operation here would be to untie your shoe. And if you untied your shoe, you could tie your shoe. Both of these go back and forth. They undo each other. Taking the train downtown from West Chicago would be taking the train from downtown to West Chicago. Those are inverses. Something which undoes or puts it back into its original state. So if you look again at our numbers here that we used, we started with 8, we had a plus 4 and then a minus 4, and it got us back to our original state. So we would say that the plus 4 and the minus 4 were inverse operations. We started with 30 and we ended up at the original state of 30. We'd say that dividing by 3 and multiplying by 3 are inverse operations. So when we say a mathematical operation, we mean something used to combine numbers or variables. This could be something like a plus, a minus, division, multiplication, could be a square root, could be a squared, all sorts of different things. We'll talk about something called logs later on this year. Anything that's a mathematical symbol that changes the number or the variable is a mathematical operation. The really cool thing for us here is that every mathematical operation has an inverse, every single one. We already saw how we're going to be pairing some of these together, and throughout the year we'll talk about the other ones and where you see the inverse. So keep an ear out for that as we go through each chapter. Anytime we learn about a particular symbol or a particular concept, we're also going to talk about what's the inverse for that concept. Today, though, we're just going to talk about two, which you already know about. We're going to talk about the plus and the minus ones. So the plus and the minus ones we actually call the additive operations, additive, additive pairs, are called opposites. So when you combine opposites, you should get 0. For example, here's 4. What is the additive inverse is what we would say, or what's the opposite of 4? The opposite of 4 is negative 4. Negative 2/3. What is the additive inverse, or what's the opposite? Opposite of negative 2/3. And when you see the opposite and the negative together, we know that those cancel and we just get positive 2/3. What's the additive inverse of negative 3 plus a? Again, we know that we have a negative outside here. We'll distribute that to each. So we'll get positive 3 minus a. They just change the signs. Now, when you combine opposites, you should get 0. So if we said positive 4 plus negative 4, yeah, that'd be 0. Negative 2/3 plus 2/3, that would be 0. Negative 3 plus a plus positive 3 minus a, absolutely. The negative 3 and the 3 would cancel, the a and the negative a would cancel. We'd still get 0. So you're familiar with those. Those are called opposites, or the additive inverse. Oops, sorry. This next one that you also are familiar with, these ones are the multiplication and the division. So we call these the multiplicative pairs. These are called inverses, or reciprocals is the word you're used to hearing. The reciprocals. When you combine reciprocals, you don't get 0, that's for opposites, you get 1. So reciprocals, when you combine them, give you 1. Same numbers as before, 4, negative 2/3, negative 3 plus a, but now we want to find the reciprocal. Multiplication and division. So for 4, the way you get a reciprocal is you always say 1 over whatever this is. That's your reciprocal, is 1 over something. So 4 and 1/4. When we combine these, when we say what is 4 times 1/4, we'll get 1. For this one here, 1 over negative 2/3, we get a complex fraction. You may remember about complex fractions, if you have a fraction in the bottom, you rewrite it like this. You say 1 times, and you flip the lower fraction here. So this really gives us negative 3/2. That would be our reciprocal. If we multiply negative 2/3 times negative 3/2, negative times a negative will cancel, and the 2 and the 3 here will cancel with the 3 and the 2 there, we should also get 1. Reciprocal for this one, this would be 1 over negative 3 plus a. Now, if you have a fraction on the bottom like this, you are allowed to flip it. This is not a fraction. This is just an expression, and there's plus and minus symbols in here. So we're not going to do any flipping. We're just going to leave it as is. But if we were to multiply this 1 over negative 3 plus a times the quantity, we could say that these two cancel, and we just get 1. So reciprocals give you 1. Opposites give you 0. Those are the two I want you to focus on for the start of our chapter here. Two more things about inverses really quick. The equation that you see here, think about how you would say this using words. We would say 2 times x plus 9 equals 3. Pay attention to the mathematical operators. We have the word times and we have the words plus. Then, think about how you would solve it. Well, we need to move over the 9, so we'd say subtract 9 from both sides. And then once we got the 9 away from both sides, let's see, we'd have 2x equals negative 6. Now we'd have to get rid of the 2, so we'd have to divide both sides by 2. And if we divided both sides by 2, we should get x equals a negative 3. Pay attention to the words we just used here. We just used the words subtract and divide. Notice times and divide. We divided by 2, it was multiplied by 2. We subtracted 9, and it was plus 9. They're the opposites or the inverses. So when you're solving equations, you're already using inverse operations to help you solve. You're doing the opposite. You're undoing something. So PEMDAS. In PEMDAS, remember what this stands for? Please excuse my dear Aunt Sally. That helps us remember parentheses, exponents, multiplication, division, addition, and subtraction. Those are our symbols. Notice these two together, notice these two together. Those are the ones we just talked about as being inverse operations of each other. The M and the D and the A and the S, they go together. So, inverse operations, anything that undoes something else. That's what we talked about. How plus and minus are inverse, multiplication, division are inverse. The other big idea we had is that every mathematical operation has an inverse. So keep your eye out. We're going to see them throughout the year.